January 17, 1940, Newark, New Jersey. The machines hum in steady rhythm. Sparks fly from grinding wheels. The air smells of hot metal and machine oil. In the corner, an older man with weathered hands inspects a ceramic cylinder no larger than a fountain pen. He holds it up to the light, turning it slowly, checking for hairline fractures that would doom an engine at 20,000 feet. Outside, a nation still at peace. Inside, Albert Champion examines the small white object that will decide the fate of empires. This is not a spark plug, not yet. This is insurance against darkness. A promise that when young men climb into the cockpits of fighters and bombers, when they push throttles forward and feel engines roar to life, those engines will not fail. That the spark will come. That the fire will ignite. That they will return. But in 1917, America possessed none of these. Zero. Not a single spark plug suitable for aircraft engines existed on American soil. Spring 1917. The declaration of war. When President Woodrow Wilson stood before Congress and asked for a declaration of war against Germany, the United States Army Air Service owned exactly 55 aircraft. Not 500, not 5,000, 55. And of those 55, most were trainers. Biplanes with fabric wings and rotary engines that sputtered and coughed like old men climbing stairs. None were fit for combat over the Western Front, where German Fokkers and Albatross scouts ruled the skies with synchronized machine guns and engines that could sustain high-altitude flight. The American industrial machine, already the largest in the world, already producing more steel and coal than any nation on Earth, faced a singular, humiliating problem. It could not produce the one component that every aircraft engine required to function: the spark plug, specifically the high-compression, high-temperature, high-altitude spark plug needed for military aviation. American automobile spark plugs worked fine at sea level, in cars that traveled 30 miles per hour on smooth roads. But at 15,000 feet, where temperatures plunged to 20 below zero and air pressure dropped by half, those same plugs failed. The porcelain cracked, the electrodes fouled, the spark died, and with it, the engine. European manufacturers had spent years perfecting aviation spark plugs. Bosch in Germany, Lodge in Britain, Champion in France. They understood the metallurgy, the ceramic formulations, the precise gaps and heat ranges required. America had none of this knowledge, and when war came, when the government placed orders for thousands of Liberty engines, the 12-cylinder power plants designed to propel American bombers and fighters into battle, there was nothing to ignite them. This is where Albert Champion enters the story. Not as a savior arriving at the perfect moment, but as an immigrant who had been preparing for this moment for 20 years without knowing it. Paris, 1889. A bicycle mechanic's son, Albert Champion was born in the shadow of the Eiffel Tower's construction, in a Paris already drunk on speed and machinery. His father repaired bicycles. Young Albert raced them. By his teens, he was winning races across France, his legs pumping, his lungs burning, his mind calculating gear ratios and wind resistance and the limits of human endurance. He understood that victory came not from wanting it more, but from reducing friction, from making every component work in perfect harmony. When motorcycles arrived, Champion shifted to them. He raced across Europe, setting speed records, crashing spectacularly, surviving and racing again. But racing taught him something more valuable than trophies. It taught him that the engine was everything, that a machine could be beautiful and aerodynamic and perfectly balanced, but if the spark failed, if combustion did not occur at the precise millisecond required, then all of it meant nothing. The engineering, the courage, the speed, nothing. So Champion stopped racing and started building spark plugs. He studied porcelain. He learned that the ceramic insulator had to withstand not just heat, but thermal shock. The violent transition from combustion temperature to frigid outside air repeated thousands of times per hour. He experimented with electrode materials, discovering that pure copper conducted heat too quickly, causing pre-ignition, while pure nickel resisted heat but wore down too fast. He found the balance. By 1905, Champion had founded a small spark plug company in Paris. By 1908, he had immigrated to America, carrying with him the knowledge that American manufacturers lacked. He settled in Boston, then Flint, Michigan, building spark plugs for the nascent American automobile industry. His plugs were better, more reliable. They didn't foul as quickly. Mechanics began requesting them by name. But Champion's plugs were still designed for automobiles, for engines that ran at low altitude, low compression, low temperature. He had no reason to think about aircraft. America had no aircraft industry. Aviation was a curiosity, a sport for daredevils and wealthy enthusiasts. Then came the war, the panic. The Signal Corps, responsible for military aviation, placed urgent orders with American spark plug manufacturers. They needed plugs for the Liberty engine, a powerful, high-compression V12 designed to outperform anything in European skies. The engine produced 400 horsepower. It could propel a bomber at 100 miles per hour at 15,000 feet, but only if the spark plugs worked. The first tests were catastrophic. Standard automobile plugs failed within hours. The porcelain cracked from thermal shock. The electrodes fouled with carbon deposits. Engines sputtered and died, leaving test pilots gliding back to Earth, praying their altitude would carry them to a safe field. The military demanded solutions. Engineers worked around the clock, and still the plugs failed. The problem was porcelain. Porcelain, fired clay essentially, had to be dense enough to insulate the electrical charge, porous enough to resist cracking, and pure enough to withstand 800 degrees Fahrenheit without breaking down. American porcelain manufacturers, accustomed to making dinnerware and insulators for telegraph lines, could not produce porcelain with the necessary properties. Their formulations contained impurities. Their firing techniques were inconsistent. The porcelain that worked in a teacup shattered in an aircraft engine. This is what Champion understood that others did not. The spark plug was not a mechanical problem. It was a materials science problem, and Champion had spent 15 years solving it. Newark, 1918. The factory expands. Champion's company, by now renamed AC Spark Plug, received a contract from the US government. They needed 1 million spark plugs for the Liberty engine. Delivery required within 18 months. Failure was not an option. Champion redesigned everything. He imported raw materials from France, high-purity alumina for the porcelain, rare earth elements for the glaze. He redesigned the firing kilns to maintain precise temperature gradients, ensuring that every plug was fired identically. He created new electrode alloys, blends of nickel, chromium, and copper that could withstand extreme heat without eroding. He designed new gaskets, new threading, new heat dissipation channels. Most critically, he standardized production. Before Champion, spark plugs were semi-custom items. Mechanics adjusted gaps by hand. Tolerances varied. Each plug was slightly different. Champion built machines that could produce 10,000 identical plugs per day. Every gap was precisely 0.025 inches, every torque specification exact, every component interchangeable. This was the quiet revolution. Not just a better spark plug, but a production system that could scale. That could turn 1 million plugs from an impossible demand into a logistical challenge. That could transform a nation with 0 aviation spark plugs into the world's largest producer within 2 years. By November 1918, when the armistice ended the First World War, American factories were producing Liberty engines faster than airframes could be built to house them, and every engine carried Champion spark plugs. But the First World War ended too soon for American aviation to prove itself in combat. The Liberty engine never saw significant action over the Western Front. The thousands of bombers and fighters built in American factories arrived in Europe after the fighting stopped. The spark plugs sat in crates, unused. Albert Champion had solved a problem just in time for it to become irrelevant, or so it seemed. September 1939. Poland burns. 2 decades pass. Albert Champion dies in 1927, his company absorbed into General Motors. The Liberty engine becomes obsolete. Biplanes give way to monoplanes. Fabric gives way to aluminum. Radial engines give way to inline engines, and then to turbocharged engines, and then to engines producing not 400 horsepower, but 2,000. And every single one requires spark plugs. When Germany invades Poland, when Britain and France declare war, when the Luftwaffe demonstrates that air superiority determines the outcome of modern warfare, the United States is still officially neutral. But American factories are already preparing, and this time they do not start from zero. The knowledge Albert Champion brought to America, the porcelain formulations, the electrode metallurgy, the precision manufacturing, has become embedded in the American industrial base. AC Spark Plug, now a division of General Motors, employs thousands. Other companies have learned from Champion's innovations and developed their own. Champion, Lodge, Autolite. America possesses not just the capability to produce aircraft spark plugs, but the capability to produce them at scales unimaginable in 1917. This is what totalitarian regimes never understood about democracies. They saw the chaos of free markets, the inefficiency of competition, the apparent waste of multiple companies producing similar products. What they failed to see was that this chaos was rehearsal, that competition bred innovation, that the existence of multiple suppliers meant that if one factory was bombed, others would continue. That the same industrial base producing spark plugs for civilian automobiles could pivot to military aircraft in months, not years. Germany had Bosch, one company. Excellent engineers, state-of-the-art facilities, close ties to the Nazi government. But one company. America had a dozen spark plug manufacturers, each competing for contracts, each trying to build a better plug than their rivals. And when war came, this competition became collaboration. December 1941. The arsenal awakens. The attack on Pearl Harbor transformed America overnight. Factories that built refrigerators began building machine guns. Automobile plants retooled for tanks. Shipyards that had been silent for 20 years roared to life, laying keels for destroyers and aircraft carriers. And spark plug factories, already experienced, already equipped, simply accelerated. AC Spark Plug's Flint, Michigan facility expanded to cover 100 acres. Inside, machines stamped out electrode shells at a rate of 1 every 2 seconds. Conveyor belts carried them through heat treatment furnaces, through threading stations, through testing rigs where every plug was checked for electrical resistance and compression. 24 hours a day, 7 days a week, plug after plug after plug. The numbers are almost incomprehensible. Between 1941 and 1945, American factories produced more than 300,000 aircraft. Fighters, bombers, transports, trainers. Each aircraft carried at least one engine. Most carried 2. Heavy bombers like the B-17 Flying Fortress carried 4. Each engine required between 18 and 24 spark plugs, depending on cylinder count and configuration. And spark plugs wore out. They fouled. They cracked. They had to be replaced every 50 to 100 flight hours. Multiply it out. 300,000 aircraft. Assume an average of 2 engines per aircraft. That's 600,000 engines. Assume 20 spark plugs per engine. That's 12 million spark plugs just for initial installation. Now factor in replacements. Assume each aircraft flies, on average, 500 hours during the war. That's 5 to 10 replacement sets of plugs per engine, another 60 to 120 million spark plugs. Conservative estimate. 150 million aircraft spark plugs produced during World War II, and that's just for American aircraft. Add in spark plugs for trucks, tanks, jeeps, landing craft, generators, and the number approaches 250 million. 250 million descendants of the spark plug Albert Champion, perfected in 1918. January 1943, Schweinfurt, Germany. The ball bearing factories. The 8th Air Force launches a daylight bombing raid against Schweinfurt, targeting the factories that produce ball bearings for German aircraft engines. 60 B-17 flying fortresses, each carrying a crew of 10 men, each powered by 4 Wright R-1820 Cyclone engines, each engine fitted with 18 spark plugs, climbed to 25,000 feet. At that altitude, the temperature outside is 40 below zero. The air is so thin that crews require oxygen masks. Contrails stream from the wingtips. Anti-aircraft shells explode in black puffs, shaking the bombers, sending shrapnel tearing through aluminium skin. And through all of it, the engines run. Not perfectly. Engines overheat, cylinders develop detonation, oil pressure fluctuates. But the spark plugs, those small ceramic cylinders that Albert Champion designed 2 decades earlier, continue to fire. 20 times per second per cylinder, 360 sparks per second per engine, 1,440 sparks per second per aircraft, hour after hour. Some bombers lose engines over the target. Flak severs fuel lines, punctures oil coolers, damages superchargers. Pilots feather propellers, shut down failing engines, and limp home on 3, on 2, sometimes on 1. But the spark plugs keep firing. Even as wounded bombers descend, as pilots nurse throttles and pray for the English coast to appear through the clouds, the spark plugs continue their work. This is the invisible victory. Not the bombs dropped, not the factories destroyed, but the 10,000 components that functioned exactly as designed under the worst possible conditions. The spark plug is one of those components, unnoticed when it works, catastrophic when it fails. German pilots, shooting down American bombers over Schweinfurt, do not think about spark plugs. They think about ammunition, about fuel, about the shrinking number of experienced pilots in their squadrons. But German engineers, examining captured American engines, notice immediately. They disassemble the Wright Cyclones, they measure tolerances, they study the spark plugs, the electrode wear patterns, the carbon deposits, the condition of the porcelain. And they realize what they are facing, the abundance. This is what totalitarian efficiency could not replicate. Not the spark plug itself. German engineers could copy the design, could manufacture equivalent plugs, but the system that produced 250 million of them, the supply chain that delivered raw materials from mines in Montana and Michigan to factories in Flint and Newark, the quality control that ensured each plug met specifications, the logistics network that transported plugs from factories to ports, from ports to airfields in England and North Africa and the Pacific, from airfields to maintenance crews who installed them in engines, in aircraft flown by young men who never thought about what happened inside their engines, who simply trusted that when they advanced the throttle, the spark would come. This was American abundance. Not wealth, not luxury, but the capacity to produce essential components in quantities that eliminated scarcity as a limiting factor. A B-17 crew flying over Germany did not ration spark plugs. They did not nurse worn plugs through one more mission, hoping they would last. Maintenance crews replaced plugs on schedule, tossing the used ones into scrap bins, installing fresh ones without a second thought. German mechanics, by contrast, cleaned and re-gapped used spark plugs, reinstalled them, prayed they would last another flight. Japanese maintenance crews, desperate for supplies as American submarines strangled shipping lanes, scavenged spark plugs from damaged aircraft, from captured equipment, from their own dwindling stockpiles. They made do, they improvised, they stretched resources thinner and thinner. American crews did not improvise. They used what worked and discarded what didn't. This was not waste. This was logistics as a weapon. This was the industrial might of a continent-sized democracy, protected by oceans, fed by the most productive farmland on Earth, powered by oil fields that had not yet begun to run dry. Albert Champion could not have imagined this. He died in 1927, 14 years before Pearl Harbor. He never saw a B-17, never saw a P-51 Mustang escorting bombers to Berlin and back, never knew that the spark plug he designed to solve America's problem in 1917 would become one of the 10,000 components that made American air superiority possible in 1944. But he built the foundation. He brought the knowledge. He transformed an idea from Europe into an American industry. And that industry, barely visible, never celebrated, never mentioned in headlines, kept engines running. April 1945, Berlin. Soviet artillery pounds the city. American and British bombers have already reduced much of Berlin to rubble. The Reichstag is a burned shell. Hitler retreats to his bunker. The Luftwaffe, once the terror of Europe, has been reduced to a handful of jets and propeller fighters flown by teenagers with 30 hours of training. Among the ruins, German engineers destroy documents, bury prototypes, prepare for the end. Some will be captured by Soviet troops. Some will surrender to Americans. Some will disappear into the chaos of a collapsing empire. But before the end, some of them write reports, technical assessments, autopsies of a defeated air force. And in those reports, buried among analysis of tactics and pilot training and fuel shortages, there are notes about logistics, about supply chains, about the small components that kept Allied aircraft flying while German aircraft sat grounded, waiting for parts that never arrived. One report, written by a Luftwaffe technical officer and recovered after the war, contains a remarkable observation. The Americans did not defeat us with superior aircraft, the officer wrote. Our jets were faster. Our pilots, when experienced, were equal or better. They defeated us with superior supply. They could lose 100 bombers in a single raid and return the next day with 100 more. They could damage engines and replace them overnight. They had no part too small to matter, no component too trivial to supply in abundance. We fought a war of scarcity against an enemy that had eliminated scarcity. This was the true asymmetry. The officer did not mention spark plugs specifically, but he didn't need to. The spark plug is a representation, a small part representing a larger whole. It represents every bolt, every wire, every gasket, every mundane component that an aircraft requires to function. It represents the unglamorous, invisible infrastructure of victory. Albert Champion's contribution to World War II was not a wonder weapon. It was not radar, not the atomic bomb, not the proximity fuse. It was reliability. It was the assurance that when a pilot thumbed the starter, the engine would catch, that the spark would come. Newark, 1945. The factory floor again. The war ends. VE Day in May, VJ Day in August. Across America, factories begin the long process of conversion back to civilian production. The orders for military spark plugs slow, then stop. Workers return home. Machines are retooled for automobile engines, for tractors, for the post-war boom. On the factory floor, a younger engineer, perhaps trained by someone who was trained by Champion himself, inspects a spark plug. Not for a bomber, not for a fighter, for a Chevrolet, or a Ford, or a Buick. The war is over. The emergency has passed. The nation that began World War I with 0 aircraft spark plugs, that entered World War II with the capacity to produce millions, now possesses the capacity to produce hundreds of millions. For cars, for lawnmowers, for boats, for all the peaceful machinery of a prosperous democracy. But the knowledge remains, the formulations, the manufacturing techniques, the precision tooling. It remains in factories, in engineering textbooks, in the institutional memory of companies like AC Sparkplug. It remains ready. This is the deeper legacy. Not the spark plugs themselves, which wear out and are discarded, but the capability to produce them. The knowledge that scarcity is not inevitable, that supply chains can be built, that an immigrant with an idea and a willingness to work can create an industry, that democracy, for all its apparent chaos and inefficiency, contains within itself the capacity to outproduce tyranny by an order of magnitude. The epilogue. There is a small museum in Flint, Michigan. Among the exhibits, vintage automobiles, industrial machinery, photographs of assembly lines. There is a display case containing a single AC spark plug from 1918. Next to it, a spark plug from 1945. They are nearly identical. Same basic design, same porcelain insulator, same electrode gap. 27 years apart, and the fundamental design has not changed, because Champion got it right the first time. The placard does not mention that this spark plug helped win 2 world wars. It does not calculate how many bombers returned safely because their engines kept running, how many pilots survived because the spark did not fail at the moment they needed it most. It simply notes that AC Sparkplug, founded by French immigrant Albert Champion, became one of the largest spark plug manufacturers in the world. But stand there long enough, looking at that small ceramic cylinder, and you begin to understand what it represents. It represents the idea that democracy's strength lies not in its ability to produce heroes, but in its ability to produce solutions. That freedom creates an environment where an immigrant bicycle racer can become an industrialist, where competition breeds innovation, where the solution to a national emergency can come from a factory in New Jersey, run by a man who learned his craft in Paris and brought it to Michigan. It represents the 10,000 unglamorous components that make modern life possible, the bolts that hold together bridges, the wires that carry electricity, the valves that control water flow, the spark plugs that ignite engines. These are not celebrated, they are not remembered, but remove them and everything stops. And it represents the fundamental difference between systems that trust their people and systems that control them. Totalitarian regimes centralized production, eliminated competition, demanded efficiency. And they were efficient until the system was disrupted, until the central plan failed, until the one factory producing the critical component was bombed or sabotaged or simply could not keep up with demand. Democracies built redundancy, multiple companies competing and collaborating, multiple supply chains, multiple solutions to the same problem. It looked wasteful, it looked chaotic, and it was. But when the crisis came, when the war came, this chaos revealed itself as resilience. Albert Champion died wealthy but not famous. No monuments bear his name, no holiday commemorates his contributions. He is a footnote in the history of American industry, a name on a patent, a founding story for a company that was eventually absorbed into a larger conglomerate. But his spark plugs flew in every American aircraft in World War II. They powered the bombers that destroyed Hitler's war machine. They powered the fighters that swept Japanese Zeros from Pacific skies. They powered the transports that carried paratroopers over Normandy, the reconnaissance planes that photographed enemy positions, the trainers that taught hundreds of thousands of young men to fly. They kept the spark alive. And in the end, that is what democracy requires. Not grand gestures, not charismatic leaders, not wonder weapons. It requires the spark, the ignition, the moment when fuel and air and electricity combine to create power. It requires that spark to come reliably, repeatedly, millions of times, without fail. Albert Champion gave America that reliability. He came from France with knowledge. He built an industry. He solved a problem that in 1917 threatened to ground American aviation before it could take flight. And 24 years later, his solution helped ensure that American aircraft would dominate the skies over Europe and the Pacific, that engines would run, that pilots would return, that the spark would never fail when it was needed most. This is the inheritance of immigration, of expertise crossing borders, of knowledge shared and adapted and scaled, of a single inventor's insight becoming a nation's capability. In 1917, America had 0 aircraft spark plugs. By 1945, America had produced 250 million, and every single one traced its lineage back to a French immigrant who understood that victory depends not on the size of the army, but on the reliability of the spark.